Hello, this is Brian Caslis for Lattice Semiconductor. I'm going to show you the simulation flow using the Lattice Diamond 1.3 software. So here I have my Diamond start page, which you can see in the overview. I'm just going to open my existing project. So in this project here, as it opens, here's my process list, and you can see the various processes that are run. The thing I want to point out for simulation is some of these processes have sub-processes, such as in the map and the export files. There I can generate simulation files for. So in map design I can generate Verilog or VHDL simulation files, and same thing in my export files, I can generate Verilog or VHDL simulation files, or both. And these are important that if I want to take and simulate at those levels, I have to have done those previously in the process list before I take and go and run my simulation wizard. Okay, for running simulation in Lattice Diamond 1.3, which is different than in previous version, let's go to our file list. And now in this version of the software, for each one of these files, I can take source files, I can take and right click, and I've now got a include for menu where I can say include for simulation synthesis, include for synthesis only, or for simulation only. So for example, these two files here are included for simulation and synthesis, whereas this file here is included for synthesis only, and these two files here are included for simulation only. So this allows me to do a variety of things. First, here's my test bench, so I can take and have my test bench be for simulation only. In addition to a single test bench, I could also have very complex designs where I have a test bench structure composed of multiple files. I can have those represented here rather than just having to use a single test bench file. In addition, I can have any single module represented differently in simulation or in synthesis. So for example, for synthesis, I've got a Verilog version of this top level of my design, which will be used for synthesis, and for simulation, I've got a VHDL version of this one to use. This shows you that you can differentiate and now have not just test bench support, but the ability to have different files available here. Also, if I didn't have an existing test bench file, if I wanted to create one, I can go and generate my hierarchy, which you see here, and I can go to my hierarchy view, and for any of these levels here, say for this top level, I can right click and I can generate either a Verilog test bench or template, or I can VHDL template, a test bench template, depending on which level of software I have. So in this particular case, it's using the Verilog file here, so that's why it says a Verilog test fixture template. So I have the ability to generate test bench templates from the hierarchy view, which I can then use in the file view. But I have an existing one here for my test bench view. So I've got my simulation files ready to run. The next thing I want to do is run the simulation wizard to export these to the simulator. So I can go up here and say simulation wizard, which will start this. And then I can give it a name. So let's call it this, and then I can select a choice of simulators. In this case, I just have Active HDL installed here. And it tells me it doesn't exist. It asks me to create it. And then from the process stage here, I can select which level to actually take and run simulation on. So this is important. The RTL is the view that we're seeing here, but where I showed you in the process list for the files produced by map would be used for this level, and you can select the language, and the files produced on the export would be used for this level, the gate level design plus timing files. So I can select whichever level I want to run simulation on. In this case, I want to run my RTL simulation. I'll go to my next stage, and now new in this version of software, it figures out which files are for simulation or simulation synthesis or simulation only, and it can automatically parse them and set the file compilation order once it parses them. So let it run to the next step, and here you can see it went and actually parsed the design, figured out my top level module is my test bench, which is correct. And once that's set, I can go to my next level, and it shows you a summary of everything that's here, and then gives me an option of whether I want to take and run the simulator or not. So I can either just save this as a script file, or I can actually invoke the simulator. In this case, I'll invoke the simulator, so I'll click Finish. And you see it opens the active HDL simulator, runs the necessary compilation here. And now I can take and go over here and initialize my design. So initialize the simulation, and you can see the structure here, and at my top level I'll select my test bench. I can go to a signal here, and I'll select them all and add them to the waveform display, which you can see here, and then run a simulation command, and you can see the waveform for the simulated counter design. In addition to loading the files, compiling them, and allowing me to run, there are a number of design options which will automatically get set. So if I look at my design settings, you'll see things like the top level, and you can see the test bench. So this was automatically set by the simulation script. When we set the test bench as the top level, it automatically passes information here. And if I was running a lower level design which had an SDF file for timing back annotation, that would be automatically loaded and set in these design options also. So this is just a brief overview of how to run simulation in Lattice Diamond. As you can see in Lattice Diamond 1.3, we have a complete simulation flow which allows you to load all of your design files into Lattice Diamond to be able to set the various options and then export and load them into the simulator and allow you to take and run your simulation.